Imagine for a moment that you're walking across a bridge, when suddenly it starts to curve so much that it transforms into an infinite tunnel that could lead anywhere in the universe. Or worse, that it becomes a bottomless pit from which you could never escape. Sounds like science fiction, doesn't it? But what I've just described are two of the most extreme and fascinating realities of our cosmos: black holes and wormholes. And today, cosmic explorers, we're going to dive into a journey that will reveal how the very fabric of space-time can behave in such extraordinary ways that they defy our imagination. Get ready to discover why one of these phenomena can be a cosmic prison from which not even light can escape, while the other could be the key to instant travel across the universe. By the end of this video, you'll understand why Albert Einstein would be simultaneously fascinated and terrified by these discoveries, and how they could completely revolutionize our understanding of time travel and space exploration. Welcome once again to Cosmic Frontiers, the channel where we unravel the deepest mysteries of the universe. And speaking of mysteries, we're on an incredible journey towards our first 1,000 cosmic explorers. And each one of you is fundamental to this adventure of discovery that we're building together. Let us start our exploration with something that truly exists and that we know to be real: black holes. Imagine a region of space where gravity is so intense that not even light, the fastest thing we know in the universe, can escape. It's as if someone created a hole so deep in reality that everything that gets close simply vanishes forever. But how can something like this exist? The answer lies in the very nature of space and time. Einstein taught us that space and time aren't just an empty stage where things happen. In fact, they form a flexible fabric called spacetime, which can be curved and distorted by the presence of mass and energy. Imagine a tightly stretched trampoline. If you place a bowling ball in the center, it will create a depression. Now, if you roll a ping-pong ball near that depression, it will start to orbit the bowling ball and might even fall into the hole. This is a simple analogy for how gravity works. Massive objects curve space-time, and other objects follow these curvatures. A black hole is what happens when this curvature becomes so extreme that it creates something like an infinite well in space-time. They form when a very massive star, at least 25 times heavier than our Sun, reaches the end of its life. When the star's nuclear fuel runs out, there's nothing left to counterbalance its own gravity. The star then collapses in on itself in a fraction of a second, concentrating all its mass into an infinitely small point called the singularity. The result is something truly extraordinary: a region of space where gravity is so intense that it creates what scientists call an event horizon. Think of the event horizon as an invisible boundary in space. Once something crosses that boundary, there's no turning back. It's like a cosmic waterfall where everything that goes over the edge is inevitably pulled down. The difference is that, in the case of a black hole, there isn't a down in the traditional sense, just an infinite curvature of spacetime. Now, here's something that will blow your mind. If we took a teaspoon of material from a black hole, it would weigh approximately 6 billion tons. To get an idea of this absurd density, it would be like compressing the entire mass of Mount Everest into a grain of sand. And remember, this isn't science fiction, this is proven scientific reality. We've already detected gravitational waves produced when two black holes collide, confirming that these cosmic monsters truly exist. But now we're going to enter much more speculative and equally fascinating territory: wormholes. Unlike black holes, which we know exist, wormholes are still purely theoretical. They emerge from Einstein's equations of general relativity as a mathematical possibility, but they've never been observed in reality. A wormhole would be like a tunnel in space-time that connects to distant regions of the universe, or even different universes. Imagine you made a hole in a piece of paper and folded the paper so that this hole aligns with another hole in a different part of the paper. Now you could pass a pencil from one hole to the other without traversing the entire surface of the paper. A wormhole would work similarly, but with the very fabric of space-time itself. The most fascinating idea about wormholes is that they could function as instant portals across the cosmos. Imagine being able to enter a wormhole on Earth and exit on the other side near a star 1,000 light-years away, all in a matter of minutes or seconds. It would be like having a cosmic expressway that would allow us to explore distant galaxies without waiting thousands of years to get there. But there's a fundamental problem with wormholes. According to our current understanding of physics, they would be extremely unstable. a natural wormhole would collapse almost instantly, closing the tunnel before anything could pass through it. It's like trying to keep a soap bubble open in a storm, practically impossible. To keep a wormhole open, theoretical physicists believe something called exotic matter would be needed, a type of matter with very strange properties, including negative energy density. This exotic matter would push spacetime outward instead of pulling it inward, thus keeping the tunnel open. The problem is that we've never detected exotic matter in nature, and we don't even know if it can truly exist. Now, let's directly compare these two fascinating phenomena. Black holes are like ultimate cosmic prisons. Everything that enters never comes out. They devour matter, energy, and even space and time themselves. In contrast, a wormhole would be more like a cosmic revolving door, allowing matter and energy to pass from one side to the other. From a physics perspective, the fundamental difference lies in the structure of space-time. A black hole has a singularity at its center, a point where the laws of physics as we know them simply break down. It's like reaching the end of a map where it says here be dragons. A wormhole, on the other hand, wouldn't have a singularity, but rather a throat that connects to regions of space-time. There's also a crucial difference in terms of the event horizon. A black hole has an event horizon from which nothing can escape, but a traversable wormhole, in theory, wouldn't have a real event horizon. You could enter on one side and exit on the other without crossing a point of no return. Stephen Hawking, the physicist who revolutionized our understanding of black holes, discovered something extraordinary. Black holes aren't completely black. They actually emit a very faint radiation called Hawking radiation. This discovery showed that black holes have temperature and can even evaporate over trillions and trillions of years. It's like discovering that the deepest well in the universe actually has a small leak. On the other hand, if wormholes existed, they could have even more revolutionary implications. Some theoretical physicists speculate that they could not only allow instant travel through space, but also through time. If one side of a wormhole were accelerated to speeds close to that of light, Einstein's special relativity tells us that time would pass more slowly on that side. This would create a time difference between the two ends, potentially allowing time travel. But here we have to be very careful and scientific. When we talk about time travel through wormholes, we're entering highly speculative territory. There are many paradoxes and theoretical problems that we still don't know how to solve. For example, the famous grandfather paradox. What if someone traveled back in time and changed something in the past that prevented their own existence? Kip Thorne, the physicist who won the Nobel Prize for his contributions to the detection of gravitational waves, was one of the main researchers to seriously study the possibility of traversable wormholes. He and his colleagues showed that, if they existed, they would have very specific properties and would require extremely special conditions to be created or maintained. One of the most intriguing questions is, if natural wormholes existed, where would they be? Some physicists speculate that they could be hidden on microscopic scales, perhaps connecting different regions of our universe or even different universes in a theoretical multiverse. It would be like having a network of secret tunnels woven into the very fabric of reality. Another fascinating possibility is that very advanced civilizations could theoretically build artificial wormholes. This would require control over exotic matter and an understanding of fundamental physics far beyond what we have today. It would be the cosmic equivalent of building a bridge, but instead of crossing a river, they would be crossing spacetime itself. It's important to note that although wormholes are mathematically possible in Einstein's equations, that doesn't mean they exist in reality. Physics is full of mathematical solutions that don't have real-world counterparts. It's like a map that shows an island that might not exist in the real ocean. Black holes, on the other hand, are regularly detected by our telescopes. We know there's a supermassive black hole at the center of our galaxy, called Sagittarius A*, which has a mass equivalent to more than 4 million suns. In 2019, we even managed to directly photograph a black hole in another galaxy, showing for the first time the dark shadow surrounded by the bright ring of matter being devoured. Here we arrive at a profound reflection on the nature of scientific discovery. Black holes began as an exotic theoretical prediction from Einstein's equations in 1915. At the time, many physicists, including Lord himself, thought they were just mathematical curiosities that would never exist in reality. But over decades of observations and discoveries, we've confirmed that they not only exist, but are fundamental to the structure of the universe. Perhaps wormholes will follow a similar path. Maybe in future decades we'll discover evidence of their existence, or perhaps we'll confirm that they're impossible in nature. That's the beauty of science. It allows us to explore the frontiers of the possible and the impossible. From the perspective of future space exploration, the difference between these two phenomena is dramatic. Black holes represent absolute dangers to any spacecraft or life form. Getting too close to one would be fatal, not only due to the intense gravity, but also due to the tidal effects that would stretch any object until it was completely destroyed. Wormholes, if they existed and were traversable, could completely revolutionize our ability to explore the cosmos. Instead of needing generations to travel to other stars, we could potentially make these journeys in a matter of hours or days. It would be like transforming the universe from an infinite ocean into a small lake that we can easily cross. But let's be realistic about the challenges. Even if wormholes existed, using them for travel would be extraordinarily dangerous. We would essentially be navigating through tunnels in the fabric of reality, where the laws of physics might behave in completely unpredictable ways. It would be like sailing in completely unknown waters without a map or compass. Research into these phenomena also teaches us something fundamental about the nature of the universe. It's much stranger and more fascinating than our daily intuition suggests. In our everyday experience, space is a fixed stage where things happen, and time flows uniformly. But cosmic reality reveals that space and time are dynamic, flexible, and can be distorted in ways that defy our imagination. When we look at the philosophical implications, both black holes and wormholes force us to question fundamental concepts like causality, determinism, and the very nature of reality. If time can be distorted and space can be traversed instantly, what does that mean for our understanding of cause and effect? Recapping the most fascinating points of our journey today. First, we discovered that black holes are real cosmic prisons, where gravity is so intense that not even light can escape. Formed when massive stars collapse and create extreme curvatures in space-time. Second, we explored how wormholes are theoretical tunnels in space-time that could connect distant regions of the universe, functioning as instant portals, but which would require exotic matter to remain stable. And third, we saw how these two phenomena represent the opposite extremes of space-time curvature, one that traps everything forever, and another that could free humanity from the limitations of cosmic distance. This leads us to a deep cosmic reflection. We live in a universe where the impossible can become real, where the boundaries between science and imagination sometimes dissolve. Black holes have taught us that reality can be more extreme than we ever dreamed. Wormholes show us that physics can imagine possibilities that transcend our current limitations. Both remind us that we are cosmic explorers on a journey of discovery that is just beginning, navigating a universe that continues to surprise and humble us with its grandeur and complexity. Cosmic explorers, now I want to hear from you. If you could choose between observing a black hole from a safe distance or traversing a wormhole to explore another part of the universe, which would you choose and why? Leave your answers in the comments, because I love to see how you think about these cosmic mysteries. And since we're talking about the mysteries of the universe, what fascinating cosmic phenomenon would you like me to talk about in the next video? Dark energy, multiverse, time travel. Leave your suggestions in the comments, because Cosmic Frontiers is built by all of us together. We're on an incredible journey towards 1,000 cosmic explorers, and each one of you is fundamental to this adventure of discovery. If this video expanded your horizons on the extreme possibilities of our universe, join our crew by clicking subscribe. Like this video if it made you think about the extraordinary nature of reality, and share it with someone who is also fascinated by the secrets of the cosmos. In the next video, we'll dive into another mystery that challenges our understanding of reality. So turn on notifications so you don't miss that adventure. Keep exploring, keep questioning, and remember, in a universe where black holes exist and wormholes are possible, there are no limits to what we can discover at the cosmic frontiers.